If I'm being honest, I don't know how semiconductors work, and I don't really understand all the processes that go into making them. You're telling me that you grow a crystal, slice it up using diamond, then shoot an ultraviolet beam at it and suddenly it can compute? You might as well be inscribing runes on an ancient stone and casting a spell on it to make it think. I know one thing though, that wizard casting the spell is most likely Taiwanese. That's because around 60% of the world's semiconductors are made on the relatively small island of Taiwan, over 90% if you only count the most advanced ones. But saying Taiwan is the world's dominant chip manufacturer is a little like saying me and Warren Buffett have a combined net worth of around $150 billion, which is true. For Taiwan, it's TSMC and the rest of the island's companies. Taiwan accounts for 70% of global foundry revenue, any money made from the manufacturing of chips, but the Taiwan Semiconductor Manufacturing Company alone accounts for 65% of it, and its market dominance has only grown since the AI boom, where it accounted for only 55% of market revenue at ChatGPT's launch. Put simply, TSMC is one of the world's most advanced semiconductor makers. It has the world's best technology, best facilities, and best engineers to make the most cutting-edge semiconductors. The company did this by being the first true foundry model business. In the early days of the integrated chip revolution, companies like Intel, Texas Instruments, and IBM both designed and manufactured semiconductors themselves. But as chips were stuffed with more and more transistors, roughly doubling every 2 years to now billions per chip, it was becoming ever harder for these companies to keep up with the new technologies and manufacturing costs. At the same time, they were losing significant market share to Japanese companies. To protect their profits and competitiveness, many of these companies started to outsource the manufacturing process to Asia, while keeping the more lucrative design sector in America. This is TSMC's foundry model, focusing only on the manufacturing of chips, taking requests from large companies who can't justify building their own fabs. Now, Taiwan was not an obvious choice to outsource to. From the Dutch colonization of the island to the Japanese occupation, Taiwan's main export had been sugar. It was a very poor agricultural country, having roughly the per capita output of a sub-Saharan African country. But after the Chinese Civil War and Communist victory, its history radically changed when the Nationalist Republic of China fled to Taiwan in 1949, along with over 2 million refugees. Aided by the American government, the country set out on an ambitious land reform effort, without the deaths that mainland China's reform caused. This increased total agricultural production, giving the KMT government more control over the countryside and more leeway to invest in areas outside of farming. The KMT was quite domineering in this period, declaring martial law for 4 decades while jailing and executing thousands of political dissidents. And yes, they dominated the economy too. In an attempt to industrialize Taiwan, the government put up import restrictions while subsidizing large corporations. But because they were so poor, most of these subsidies came from American aid, up to 40% of their total investment. Then, in the 60s, this was sharply reduced as Taiwan shifted to an export-oriented growth model. Taiwan became known for cheaply made, small manufactured goods, with companies like IBM starting to outsource assembly to Taiwan during this period. The government initiative that placed Taiwan at the center of global affairs didn't start until the 70s, when Taiwan opened the Industrial Technology Research Institute. This was part of an explicit plan to create a new semiconductor industry after experiencing the shocks of the oil crisis. The government lured the world's best electrical engineers, mostly those who had studied in the US, to come and create this new industry. Its first attempt, the United Microprocessor Company, worked, but found it hard to acquire technology from other countries' protections. To this day, UMC is still a top 5 foundry. The next attempt was spearheaded by Morris Chang, who had moved to the US when he was 18 to study English literature before realizing he wanted to make money and started a career as a transistor engineer at Sylvania. Here, he was reported to make dozens of transistors an hour. Dozens! Chang ended up working for Texas Instruments in 1958, helping to pioneer the mass production of chips. Here, TI focused on building their own consumer electronics from start to finish. But after he was snubbed for the CEO position, he quit after 25 years and after a brief stint at General Instruments, would take the Taiwanese government up on its offer going to work at the ITRI. In 1987, Chang founded TSMC with the goal of offering a foundry model for American and Japanese firms to technologically cement Taiwan in the semiconductor production chain. Chips were initially priced at a loss to the company, banking on the idea that the fabs to make them would grow too costly for Silicon Valley startups to build themselves. This would let them gain an early market share and increase it via the outsourcing efforts. From the start, the Taiwanese government had also funded the company. Through the National Development Fund, they owned 48% of TSMC at its initial public offering. Philips, a Dutch electronics conglomerate, owned 28%, and the rest was held by private investors, mainly wealthy families the government had persuaded into buying. Chang, the engineers, and the investors have made TSMC into one of the world's most profitable and important businesses, a top 10 company by market cap, sitting up there with big shots like Meta and Berkshire Hathaway. And we love Warren! The typical semiconductor chain goes something like this. Companies which design them, like Nvidia, Google, and Apple, those that make them, where TSMC lies, and those that use them to make this. How do you set yourself apart on the second node? You need a technological gap. TSMC, by constantly focusing on small, real improvements and not trying to balance their money between the manufacturing and designing sector, has locked them into a technological advantage for the last decade or so. For example, they spent $40 billion in research development in 2023 alone. Plus, since they're one of the only companies who can produce the most advanced chips, they essentially get part of the largest tech companies' research budgets too. What else are they gonna do? Design these new chips and never have them be made? The standard size for a silicon wafer is 300mm in diameter, or about 1 foot. That's around 70,000 square millimeters. The wafer is then split into dies, units that the integrated chip will be etched onto. But the amount of dies you can get out of a wafer depends on the size of the transistors inside. Transistors, which used to look like this, are now measured in nanometers. The most advanced chips use 3 nanometer processes, 1/20,000th the width of a strand of human hair. Though really, when you get this small, it's more of a marketing term than their actual size. You also need to expect that some dies will be unusable due to errors in making them. A single speck of dust could cause a $250,000 mistake if it lands on a wafer, why all work must be done in clean rooms. So in total, there are around 1,500 steps to make a semiconductor, each with their own procedures, materials, and equipment. The thousands of these found off of this chain need to be invested in to keep up with the innovation treadmill. Like these machines, extreme ultraviolet lithography machines. There is only one company on Earth, ASML, which has the capability to produce and export them. This is what enables anything 5 nanometers and below, making them essential for TSMC's ability to make modern chips. Each of these EUV machines weighs about 165 tons and costs up to $200 million per unit. That's the price of a Boeing 767 and the weight of 2. A modern fab can have up to 20 of them, so it makes sense for only the most moneyed companies to buy them. Samsung, Intel, and TSMC are the only ones, enabling only these 3 companies to manufacture the most advanced semiconductors. As chip demand has surged with more internet usage, 5G networks, techie cars, data centers, and the all-consuming Ouroboros god we call artificial intelligence, The technology gap between which chips can be used for these new technologies and which can't has grown. So TSMC, which can manufacture all types of chips, has seen its market dominance grow in the past few years. Ranging from 500 nanometer to 3 nanometer processes, their fabs include 5 in the Hsinchu Science Park, 3 in the Southern Taiwan Science Park in Tainan, including the current best in the world, 1 in the Central Taiwan Science Park in Taichung, 2 in China, 1 in Shanghai, the other in Nanjing, 1 in Japan with another under construction, 1 under construction in Dresden, Germany, 3 planned in Taiwan where 2 nanometer processes will start, and finally in the US, 1 in Camas, Washington, and a facility including 6 fabs under construction in Phoenix, Arizona. TSMC also has common business sense. It will never design its own chips to prevent any conflict with future customers. Don't compete with your clients. Samsung didn't learn this lesson. They had been the original maker of the iPhone's A series processors for its first 4 generations. But after launching its Galaxy phone, of course using Samsung designed and manufactured chips, Apple sued them for intellectual property theft, winning over $500 million from them and losing Samsung a valuable customer. After Intel turned them down, TSMC would take them up on the offer to manufacture the iPhone's chips, and to this day, Apple is still their single largest customer, followed by the 4 American chip designers, Qualcomm, AMD, Broadcom, and Nvidia. So despite the fact that Samsung is as advanced as TSMC in chip-making technology, their need to vertically integrate their design and manufacturing into their own products has scared away potential customers. Now, their foundry revenue is only a 1/7 of TSMC's, actually losing much of their market share since the AI boom. Business is fine and all, but it's hard to talk about TSMC without at least mentioning their geopolitical consequences in the world. China and America are both in rivalry with each other for military and AI dominance and commercially dependent on each other. Although TSMC may be the supplier to America's biggest tech companies, most of their sales actually go to China. A large part of this is the triangle tech trade, where American companies will design high-tech products, outsource the component making to Taiwan, who then outsources the assembly to Chinese plants to ship back to America. Though another part is that China is genuinely outcompeting America on key new technologies, like batteries, electric vehicles, and drones, made with and used alongside semiconductors. Both governments see their countries' dependence on Taiwanese manufacturing as a national security threat, and both have launched programs to eat away at Taiwan's market share. China does this in their typical way, by throwing billions at it. The crown jewel which has come out of this spending is SMIC, the Semiconductor Manufacturing International Corporation. Although they don't have access to the cutting-edge technology which makes TSMC so competitive, they have become the world's 3rd largest foundry, focusing on 28 nanometer processes and above. From 2022 all the way to their last week in office, the Biden administration had banned waves of the newest chips to China, including Nvidia's Ampere and Hopper GPUs, which have become the world's favorite processors to train AI on. They've also imposed caps on third countries to limit the effects of chip smuggling in Chinese black markets. Since 2023, ASML has also banned the export of EUV machines, and Japan has banned the export of 23 types of manufacturing equipment to China. Meanwhile, Biden had been pursuing a China-like policy, also throwing billions at the chip problem. While Trump thinks a more market-based approach, enticing companies to migrate using tariffs is what's needed to spur investment. Either way, investment has come in both administrations. That Phoenix facility mentioned earlier is the single largest foreign investment in American history, totaling $165 billion across its campus. This will make TSMC's advanced chips down to 5 nanometer processes in the continental United States. though there has been some friction importing the culture of the company into Arizona. American workers say TSMC has an authoritarian culture with long hours, unrealistic deadlines, and berating managers. TSMC doesn't necessarily deny this, saying their culture of discipline and dedication is what turned them into the world's leading foundry. It's unclear which exact factors have given TSMC such an advantage in chip making, and without the same culture and organization, it's unclear if the Americans can even replicate it.
American factories with American skill and American labor. And that's exactly what we're doing. As you know, Taiwan pretty much has a monopoly on that market. And I think pretty much is not a term that's even appropriate. They do have a monopoly in.
TSMC is so absolutely vital to the global economy, try to find a piece of GDP made without any semiconductors, that it's been called Taiwan's Silicon Shield. China, who claims Taiwan's territory as a part of their own, has hinted at launching a forcible reunification war this decade. However, since TSMC supplies much of the advanced chips used in military weapons and AI development, which is becoming increasingly militarized, a destruction of their facilities or embargo to China would have devastating effects on them, measured in the trillions of dollars. It also incentivizes America, Japan, and Europe to come to Taiwan's aid if a war were to break out, as they're also dependent on TSMC to keep their militaries and economies running. As China and America build more chip plants at home, it's caused some to worry that the Silicon Shield is wearing thin. If the US can self-sufficiently produce AI chips at home, what's the point of defending Taiwan? Truth is, no country can self-sufficiently make semiconductors. It is a massive supply chain, from materials to equipment to design, that many countries all across the world have quasi-monopolies over, making everyone dependent on everyone else. No country has the capacity to produce all of it inside its own borders, at least if you want the best semiconductors. And to make the best semiconductors for years to come, you're gonna have to come to Taiwan to do it. Unless, you know,